Okay, well, I'm just going to do a quick introduction to the Learning Burst series and what we're doing here. So the Learning Burst series was created to be a more informal platform to present and interact with researchers on kind of hot topic qualitative issues. My co-chair, Melissa, had the great idea of, especially with this year, doing the AAPOR talks again in an informal kind of setting. People who weren't at the conference get to hear, or people who were can hear if there have been any updates, which we certainly do not expect any updates to the AAPOR talks. But if you do have anything you wanted to add that you've found out since, that's great. But people can also ask questions and spur discussions. We are scheduling, these talks out and kind of read different talks from the program that we think. These are just meant to be more of an interactive chance to talk and just see these presentations again. So with that, we're at 11:04, and in the interest of time, I think we should get started, and hopefully more people can join as we're kind of going. So, all right.
Great. So I think I'm kicking it off, Kathleen. Is that right? All right. Yes. Well, thanks, everyone. Thanks so much for joining and giving this opportunity to share. Looking forward to hearing from other presenters as well. My name is Meyn. I work for Fluent Research. We're a small research organization based in New York City. We do both quantitative and qualitative research. We're a full-service market research company. So without further ado, I'm going to share my screen and take you through the presentation that I shared in May at the AAPOR Conference. So bear with me while I get it set up here. Great. Okay, so the name of my talk is Unlocking the Power of AI in Qualitative Analysis. I don't typically use the Teams platform, so somebody shout if you can't see or hear or if anything is going wrong, but I'll just keep on going here.
Slides Great. And sound look good, Mary. I think you're good.
All right, awesome, thanks. So as Kathleen mentioned, I was hoping I would have time to update this, but the update's going to have to be at AAPOR in 2026, which I'm looking forward to. So some of this information, I do have a little bit of new insight that I'll share, but I'll share kind of where what I shared in May. So in this presentation, I'm going to share a case study in which we used AI for qualitative analysis. And I'm going to share some high-level tips that I've learned through this process and from using AI in dozens of other, to help with analysis in dozens of other studies since this one was conducted. But there are some things that are not explicitly covered in this presentation that are really important to consider. And that is, security and privacy, particularly as it relates to your client's data, individual participant data, PII. Those are super important, need to be considered. I'm not really going to be talking specifically about this in this presentation. Some other items to be considering are the replicability of using AI tools for analysis, how using AI tools for qualitative analysis compares to traditional analytical methods. That's not what I did in this presentation, but very important to think about. And then also just considerations about the ethical use of AI. So I want to start highlighting these up front, but of course I'm not able to cover every single thing, but really important to keep those things in mind if you're considering using AI in qualitative analysis. So to start off, let's ground us in the case study, the project in which I was working. And the study I'm sharing, it is a proprietary study, and so I'm not able to share a lot about the data or the client or the goals, but I can tell you what the population we were speaking with, what we were trying to do, and how AI was helpful, and what challenges we faced in using AI for analysis. So the goals of the study, we were speaking with the sandwich generation, and you may have heard of the sandwich generation. These are people who are both caring for a young child, which in this study we were defining as a child aged 6 to 17, as well as caring in some way for an older parent. And again, in this study, we were defining it somewhat loosely in that we were looking for people who are helping to monitor their parents' physical health, maybe helping them with their medication, taking them to doctor's appointments, helping them around the house. So it was a pretty broad brush. It wasn't necessarily like physical care of their older parent, but just in some way supporting them, particularly when it came to like medical or physical needs. In other qualifications, the sandwich generation participant that we were speaking with needed to own a smartwatch. That was an important part of understanding the goals of the study. And they either needed to have a child who owned a smartwatch or a parent who owned a smartwatch. So the goal of the study, the goals of the study were
Oh, Mary, it just muted you. I'm not sure what happened.
Yeah, weird. That was funny. Thank you. So the goals of the study were to understand smartwatch or wearable device use among the sandwich generation, and then understanding, barriers to ownership among either children or adult non-users, and then understanding interest and attitudes towards health data and family health data management. So just sort of like largely understanding what are the needs of the sandwich generation as they manage their own health, their child's health, their parents' health. How do smartwatches interplay and help them monitor their health? And how might smartwatches help them manage the health of their entire family beyond just themselves? So those are the research goals. Let's see if I can, no, it doesn't want to advance my slide. There we go. So the study was designed in order to reach these goals. We did 90-minute virtual dyad interviews with participants in both the US, in 3 countries, the US, India, and Japan. And we were speaking primarily with the sandwich generation participant. And then we also spoke in this virtual dyad with their parent as well. And we conducted the interviews in the US, and we used partners to help in India and Japan. And then there was a follow-up with these families. We did in-home ethnographic interviews with 12 families, 4 in the US, 4 in India, and 4 in Japan. And this allowed us to get more context about the family dynamic, understand a little bit about like management of health records, their physical activity levels, and this allowed more data collection from the younger generation. So in these ethnographic interviews, we also got a chance to speak with the child of the household. So in terms of how we structured the interviews and the ethnographies, we were speaking to the sandwich generation about their own smartwatch usage. We also asked them about their parents' smartwatch usage, if they were a user, and their parents' potential interest or barriers in utilizing a smartwatch if they were not a user. We also asked the sandwich generation about their child's smartwatch usage or potential interest and barriers in owning. We spoke to the older adult about their own smartwatch usage or any barriers if they were not a user, and we talked to the child about their smartwatch usage. So we got the sandwich generation's perspective on themselves and also the others in their household, and then spoke to the older adult and the child about themselves only. So there's lots of different AI platforms that one could use for data analysis, and we have at Fluent now used a number of different tools that we're assessing and sort of coalescing around which tools we want to use. But in this particular case, and again, so I presented this in May. We submitted the abstract in November of last year, and so I actually collected the data, like early last year. So it's a little bit, it's been a while. We've had a lot more experience now in AI analysis of qualitative data, but in this particular project, we decided to use a tool called CoLoop, and CoLoop is specifically designed for qualitative data analysis. And the way it's structured, it's very well structured. I don't work for CoLoop. I'm not, promoting any use of one particular tool over another. I'm just giving you this one experience of how we use CoLoop. We could have used another tool, and we have used other tools, but CoLoop prompts you to set up each project. So for example, you can see the image here, create project, you enter some information about it. You can upload the moderator guide, the project goals, project description, any supporting documents that you think might be helpful. You upload all the videos, all the transcripts. And when you upload the videos, it can automatically detect different speakers. You can add them to different segments. So you see in the image down here, it has like participants, and you can indicate whether it was an older adult, the market, you know, if it was a sandwich generation in the market, to allow for analysis by market. And CoLoop works, you can query it as you might query like an LLM or you know, ChatGPT or Gemini. So here you see in the screenshot, you know, in what ways do participants use smartwatches to help with fitness? And you can, you know, look at the total sample. You can look by segment if you've set up segments. And it will, CoLoop, when you ask this question, it will generate, you know, high level, it will generate findings and supporting bullet points. And then you can actually select any of the findings and it will display quotes or relevant data directly from the transcripts. So it's really helpful in that you can, like I say, provenance, right? You can, I want to see where this is coming from, you know, or I want supporting quotes so I can put them in my report. So it's very helpful in that regard. So the advantages of using this particular analysis method, and in particular using CoLoop, CoLoop is very user-friendly. And I would say, in my experience, people who are a little bit more conservative about using AI are a little bit more comfortable with this tool for a couple of the reasons I mentioned, that it's like sort of well structured. It makes you, like, kind of takes you through a process as opposed to just like a blank slate, and the ability to click on those findings to see the quotes that back it up. I mentioned the structure, which is really, really helpful. If you were to use like a ChatGPT or Gemini LLM, I would definitely recommend providing that background material, setting up a Gem or setting up a GPT. It is tremendously helpful to provide those materials to AI in order to help your analysis. Also, CoLoop sort of forces you to structure your data. You know, it helps you identify speakers. You can list the segments. So again, it's sort of that structure that CoLoop provides is really helpful in a successful analysis. And then you have that opportunity to see the underlying data by clicking on those findings to help verify them. In terms of limitations or challenges, aside from the ones I mentioned, you know, any just overall challenges with using AI, you know, you do need to spend time arranging your data. It's time consuming to upload all the videos. Like, it takes time. It's not instant. These are rich files. If you have transcripts, you know, so in India and Japan, we couldn't simply upload the videos. We had to use transcripts because, you know, CoLoop wouldn't be able to translate those documents. So we use the transcripts. So those needed to be arranged in a way that CoLoop could analyze with the speakers labeled properly. And with any AI tool, you know, the findings have to be a starting point. They need significant edits. There are 2 bullet points here. Like, CoLoop has improved its capabilities, and also I've learned much more about its capabilities since giving this presentation. So you can give it feedback if you want it to be more succinct or more give more examples. But I do still find that sometimes the findings are bland. I don't know why. I just find that, like, they're kind of flat. And we also found it challenging that, like, it seemed like CoLoop was mixing up the findings between what the sandwich generation was saying about themselves and what they were saying about their parent or child. And so this is where it's really tricky. Like, we were speaking to this one person about their own experience as well as about their parents' experience and their child's experience. And it was all, you know, it was getting that mixed up, right? And you could see why AI would mush that together, not understanding that nuance. So that was something that I found challenging. A few other considerations when considering using AI for analysis. We now at Fluent have used multiple AI tools for even the same project. And so we call this inter-AI reliability, like inter-rater reliability, but inter-AI reliability. That allows us to leverage the strengths of different platforms and really just check the work. But there are costs to these things. You know, there's a cost per user for ChatGPT. There's a cost per user for CoLoop. So, you know, using multiple platforms is both time consuming and can be costly. And then just some specific things to keep in mind, like when it comes to the structure of your data, are you using, you know, certain concepts or mockups? You need to be really specific about how you structure your data when you share that with an AI. so that you can make sure you're querying just that subset of data. If you're talking about concept A versus concept B, it needs to be super clear what data is about concept A versus concept B. Same thing with segments. But really, like one other thing that's helpful to provide is that any debrief notes or notes from observers, those are invaluable. I mean, the element here is that you have to know your own data. You can't, just dump a bunch of information into AI and expect that it's going to give you great results. Really, you need to know what those findings are and then use your AI tool to help support your findings or shape your story. That's my advice. Yeah, so I skipped ahead, but know your data, give lots of context to your AI tool. You have to really structure your data really well, and you have to check the AI's work. It will hallucinate quotes, it will make up information, it will misinterpret things, and you have to be, super cognizant and aware of that. That completes my presentation.
Thank you so much, Mary. We're going to ask questions at the end, but if people want to put anything in the chat, feel free to do so. Okay. Oh, Michael, you're muted right now.
Okay. Hi, everybody.
There you go.
Working on sharing, which my system is being incredibly weird about. Okay. It was working before, and now it's suddenly not. Okay. Open system settings. Like that. Cancel. Share again. Got it. Okay. Share. All right. Am I successfully sharing now?
Yes, you are. Thank you.
Great. Okay. Sorry about that. Okay. Hi, everybody. Thanks so much for inviting me to this. I'm glad to be part of it and delighted to take questions in the chat and afterwards. Okay. So this is the AAPOR presentation that my collaborators and I from the University of Michigan and from the U.S. Census Bureau gave at AAPOR in May. The topic is that we are very interested, and we've had a cooperative agreement with folks at Census that is now complete, on how one can best use social media as a source for insights into public opinion. So perhaps obvious to say, but social media posts provide access to the thinking of the public, at least those who post, at an unprecedented scale that is not available or practical with other methods like focus groups. So, and this large volume of posts, often unmoderated, can include a greater range and nuance of public opinion than other methods can elicit, perhaps especially outlier and minority opinions. And this is even if the frequency of those can't be estimated, given that the population coverage in social media and how non-participants differ isn't knowable. And it may include the opinions of those who would not participate in sample surveys or formally constituted focus groups. But there's a set of challenges here. How best can we extract insights about the content, the opinions, the themes, the stances from very large corpora of social media posts? So crowdsourcing, that is eliciting human judgments about the content, has been used, but that can be slow and costly. And so we are curious about how far LLMs can take us. So it is known that LLMs can handle large volumes of text, and they can excel at summarizing and coding for content. In fact, they may be even better at some annotation tasks, that is, more accurate by an external gold standard than human crowdsource workers in some studies. And it may even be that the human crowdsource workings are employing LLMs themselves anyway. And LLMs can, in principle, provide summaries of the content of social media posts much more quickly than human analysts can. So there are a lot of LLMs to choose from. This is already old, this gives a little timeline of development of LLMs over time, and there's way more already since then. We focused on Llama 3 and GPT-4o in this study. We also were mindful of the evolving recommendations for research use. Here's a nice chart from this particular paper that particularly interested in making sure one validates whether the findings you're getting from an AI are right or not, thinking about replicability and and explainability of what your methods have been. So in the current project, our overarching question has been, to what extent can LLM summaries of social media posts from a particular corpus replicate or add to qualitative insights from other methods? And we ask a number of questions, and today I'll tell you about these as we think about alternative techniques that affect the summaries, how posts are sampled, and the choice of LLM, and then to what extent in fair comparisons do they provide equivalent or different insights about content to other methods of insight generation on the same topic. And here we'll look particularly at insights extracted from focus groups. So the focus in this study was barriers to participation in the 2020 US decennial census. That we chose this topic because we had unusual access to a 3.5 million tweet corpus, Twitter corpus of social media, Twitter posts about the US Census from January to September of 2020, which was before and during the administration of the 2020 decennial census. We had access to focus group results that had been carried out before then, but relatively recent, 42 sessions of data collection, where the focus groups had particularly been constituted to get people who wouldn't participate in, who were unlikely to participate in a representative sample survey. Also, as we reported on in AAPOR 2024, we did have sample survey results from the very same period and crowdsourced insights, but I'll focus on the other parts today. So the corpus of social media posts that we used for this was a sample of 17,497 tweets, which 0.5% random subsample of the 3.5 million corpus. The idea was to work with a more manageable size corpus that is still way too large for humans to summarize easily. The tweets had been collected based on a complex query at Census through the vendor Sprinkler. The query included the words US Census and a huge list of other inclusions and exclusions, multiple pages worth. And it includes both tweets and retweets, so there can be multiple instances of the same original tweet in the sample. The large language models we used were Llama 3.1 and ChatGPT 4.0. They are different. Llama 3.1 is open source. ChatGPT 4.0 is proprietary. They have different numbers of parameters. They have different fine-tuning capabilities. Llama 3.1 is free. ChatGPT 4.0 at the time, 4.0 at the time was a subscription plan. Here's the prompt sequence we used for both LLMs, zero shot, no training examples. I will give you a corpus of tweets related to the census. After exploring the tweets, you'll be asked a few questions about your impressions. For each of your answers, please include specific tweet numbers from the corpus to support your judgments. Use the tweet numbers provided in the input data. What were all the reasons you saw in the tweets that people gave for not filling out the census themselves or telling others that they should not fill out the census? Here's the important part. For each reason, which specific tweets by tweet number support the reason? And then we have further prompts. Which reasons seemed most important? Which reasons were rare? Which reasons were surprising? What confirmed what you already knew? And in each case, asking for specific tweets by tweet number that supported the reason. So first comparison was summaries of alternate samples. So we gave Llama 3.1 two different samples of 50 tweets that were randomly sampled from the same corpus. The prompt generated 6 reasons for each of the 2 samples for not participating in the census. Each reason cited at least one tweet that had contributed. There was one of the 2 lists of 6 reasons actually included 10 different points because the reasons were double-barreled. So here's the double-barreled examples. Worries about the census being used to advance anti-immigrant agendas and silence communities of color. Or beliefs that the census is being used to rig the system and exclude certain groups from being counted. Those are 2 quite different, in each case, those are 2 quite different points. So our first validation check was to see, did the cited tweets make sense as contributing? Largely yes, in our team's judgment, and enough to continue going down this path. But there was one very clear miss. A reason cited in one of the summaries was the belief that the census is not being conducted safely during the pandemic. When you look at the tweet that the LLM cited as having contributed to that reason, it's a very different tweet. It's about counting people in ICUs about in the US decennial census. So here's where validation was actually very helpful to say there's something off about this particular one. And that's something one could fix by our prompt specifying the U.S. decennial census in particular. There was one that seemed questionable to us. The reason that was cited, that the LLM gave, was general mistrust of the government. But if you look at the cited tweet, it seems about policy inconsistencies rather than general mistrust in government. So that one seems potentially also a little bit off. Second validation check, were the reasons listed in a single list of 6 actually distinct from each other? And in our judgment, largely yes, enough to continue going down this road. But if you look more closely at the cited tweets, it complicates things. So consider again these double-barreled issues. The tweet cited as supporting that second reason actually includes the term immigration status, which is actually in the first cited reason. Maybe perhaps excluding certain groups actually overlaps with anti-immigrant agendas in the LLM's thinking. Going further down this road, we're asking how much overlap is there in summaries of 2 different samples of 50 using exactly the same prompts? And looking at the lists, there is some direct lexical overlap. So congressional representation and allocation of federal funds and congressional apportionment seem quite similar. Excluding certain groups from being counted and undercounting certain populations seem similar. The word politicized is used in both lists. But how the same are these really? Congressional apportionment and congressional representation and the allocation of federal funds, does apportionment actually entail representation and funding allocations, or is funding allocations actually a separate reason? Or undercounting certain populations versus excluding certain groups from being counted, is undercounting a group the same as excluding it entirely? Or the census is being politicized and attempts to politicize the census and undermine its accuracy? Does undermine its accuracy actually modify, politicize the sentence, or is it actually an entirely independent reason? So our conclusion from just even this little quick investigation is that there is content overlap in the summaries derived from different samples in the same corpus. But even the similar seeming reasons are different enough to provide evidence that summaries of different samples of tweets using the very same prompts can elicit qualitatively different insights. And we expect that the degree of overlap will likely depend on the range and variability of the content in a corpus and in the samples that you get from them. Okay, so how different are Llama summaries based on a sample of 1,000 tweets versus a sample of 50 tweets? So we carried out Llama 3.1 summaries of 1,000 tweets using exactly the same prompt. And the one we're looking at here gave 29 or maybe 30 reasons compared to 6 or 10 from the sample of 50. Some reasons were very close in wording to what the smaller sample had given, like lack of awareness about the census and lack of awareness about the importance of the census. And some were very similar to each other in the list of 30. What we observed was that the behavior on the sample of 1,000 was actually much less reliable. So Llama actually ignored the request for providing evidence supporting tweets. And it also added some exact repeats of reasons. So here's the 1,000 tweet versus 50 tweet sample. There's some that very clearly overlap: lack of trust in the government, general mistrust of the government. Some seem to overlap in the general topic, but they have different nuances and are actually logically distinct. And then there's a whole bunch of new reasons that the samples of 50 had not given. And that feels important, that the larger sample does give you something that you wouldn't have gotten otherwise. And interestingly, a number of the reasons given from the larger sample overlap exactly, or they align closely with reasons that were identified in focus groups before. So as we're sort of comparing what you get from a focus group method versus an LLM summary method, the fact that there is a lot of overlap is interesting. Okay. How similar are summaries from different LLMs? Our comparison in this case was ChatGPT 4o. We used the same prompt, the same samples of 50 tweets. And in ChatGPT 4o, first you notice the output is organized quite differently. Sorry about the New York City siren going on outside, can't help it. The output is organized quite differently. There's a headline theme followed by more specific description, and ChatGPT actually gave more supporting tweets than Llama 3.1 did. Each reason that ChatGPT 4o provided in each summary was distinct, but interestingly, the summaries from the 2 samples of 50 overlapped 100%. That may be because ChatGPT uses cross-conversation, that is, subsequent prompts can build on prior prompts. So we think it's important to consider how a model uses memory in generating its summaries. For some purposes, it might be desirable to instruct the model to forget about what just happened and start from scratch. So how similar are the summaries from the different LLMs? Comparing on each side, there's some overlap. So worries about the census being used to advance anti-immigrant agendas and silence communities of color. Looks like it overlaps with people who were worried about how census data could be used against undocumented immigrants. Worries about the impact of the census on congressional representation and the allocation of federal funds seems to overlap with suspicion the census would be used to redraw political districts or for partisan advantage. But they're not really exactly the same. There are some that are quite different, actually. And we see the same issue as we saw in comparison of different Llama 3.1 outputs. Differently worded reasons, even if they have some overlap, don't mean exactly the same thing. They have different logical entailments, like which concepts include which others, and they have different nuances. And going with only one of those would lead qualitative research to somewhat different and probably complementary perspectives. So here's our perhaps unsurprising conclusions. Based on our tests with this particular research question, the particular corpus of social media posts with its range of content variability, the samples and sample sizes of posts we chose, and the LLMs we chose, that different samples of social media posts from the same corpus will produce different enough LLM summaries that pulling multiple samples is desirable. And we made a fake onion headline on the right of the very unsurprising conclusion. We're finding evidence that different words mean different things, and different LLMs actually give different enough words that they're worth paying attention to. We are seeing that larger samples of social media posts from the same corpus will provide additional summarized reasons and that provide additional nuance, but that may change the level of abstraction. And different LLMs will provide different kinds of summaries. So lots of caveats here. These are explorations with one prompting technique focused on a particular research question using samples of particular sizes from a corpus of social media posts with very particular qualities. And it's obvious that corpora can vary hugely in how focused or diffuse their content is, and thus how similar the content of samples of 50 or whatever size you choose of those posts will be. Also, our analyses are from a 2020 corpus, and platforms and user compositions have evolved significantly since then. So we see this work as exploratory and needing confirmation or expansion based on analyses of other corpora of posts. And of course, the LLMs have evolved in that time as well. But what have we learned about using LLMs for this kind of work? We would conclude that LLMs are a useful new tool in Qualitative Researcher's Toolkit, not only for understanding large corpora of social media posts, but for corpora of open-ended text more generally. I mean, everything we did here could be done with other kinds of open-ended text beyond social media. But there are limitations and practical considerations, and perhaps most importantly, constant and intensive validation of whether the results make sense is essential. So we're certainly not the first people to say this, but our explorations here have really highlighted it. And seeing what doesn't make sense can be as informative for qualitative researchers working to understand complexity in a social media corpus than what does make sense. So seeing the AI's reasoning and where it went wrong is actually, I think, informative. Attention to sampling procedures, for example, the size of the sample and, do you include retweets or don't include retweets? Those can lead to different kinds of samples in the first place, which will lead to different kinds of summaries. And I think we're also seeing that LLM summaries can overlap substantially with what other methods like focus groups and crowdsourced judgments can provide, but they're not exactly the same. And so we see this as complementary rather than replacing. So I want to thank the cooperative agreement that helped fund this, and that's it. Thanks.
Thank you so much, Michael.
All right, I think I'm up next. Hi, everyone. I'm Emily Geisen from Qualtrics, and I'm going to be talking about AI amazing responses and how we used generative AI to elevate the type of survey responses we get from open-ended questions. So our goal was really to see if we could use generative AI to enhance the quality of open-ended survey responses by asking contextually relevant follow-up questions. And this would allow researchers to gather deeper insights, enabling them to make better data-driven decisions. So let me just kind of show you our motivation a little bit more visually, I guess. So here's a typical open-ended survey question, at least for customer experience research. So you might first start with a quantitative question, how satisfied or dissatisfied someone was with their experience. And then there's going to be this open-ended follow-up question. Why did you give this rating? And we find that it's very common to get this sort of response. It was okay. It's kind of like talking to a teenager. But you already know that they were somewhat satisfied from that closed-ended question, and you want to know why. Why was the service just okay? Does anyone relate to this? Just kind of getting responses from your open-ended question that you already know that aren't actually enlightening. But let's try it again with the ability to follow up on these meh responses that lack detail. So could you share which aspects of the service met your expectations and which aspects fell short? So now we're getting somewhere, right? We have this response helping with the overhead luggage compartment. The beverages were too expensive. We understand specifically what they liked and what they didn't like. And this is the information that this open-ended response was intended to capture. So that looks cool, but are the responses actually better? So let's find out. I'm going to share results from 2 studies that we did that assess quality. So our first study used an experimental design with a general LLM. This was sort of our proof of concept. And that's actually where that first example I provided above was from. And it was good out of the box, but we wanted to create a fine-tuned model for a few reasons. Namely, improved accuracy, increased consistency, speed, cost. And so this fine-tuned version that I will show you in the second study, that's what's currently available in the Qualtrics platform. And so for our observational study, we actually pulled some data from some early adopters who use this question type in surveys earlier this year, from about November to April. But let's start with the first study, and this was our experimental study. So we conducted it with about 1,800 respondents recruited from an online non-probability panel. The topic was airline travel, and we had 2 open-ended questions, the ones that are on the right. So the first one asked why they said they were satisfied or dissatisfied, piping in their answer to that question. And then the second question asked how the airline could improve. And then respondents were randomly assigned to one of 3 conditions. Either they received no generative AI follow-ups, kind of a normal survey, or they received up to 1 follow-up question or up to 2 follow-up questions on each of the open-ended survey questions. And before I get to the results, I want to talk a little bit about our prompt engineering and how we designed it. Because I think with AI, it introduces so many possibilities that there's this temptation to boil the ocean. But we decided to focus ruthlessly on one single problem, and that is that responses to open-ended questions are not as insightful as we'd like them to be. What's the point of generating a net new question to ask if we can't even get good answers to the questions we've already asked? So these follow-ups, we designed them specifically to get more complete, detailed responses to the original question rather than asking net new questions. Secondly, we designed this with best practices in qualitative interviewing. People provide short, non-insightful responses for various reasons. Either they doubt whether their input is valid, they question the relevance of their answer, maybe they feel like their voice doesn't make a difference. So effective follow-up questions, they must really show active listening. We can't ask for information that they've already answered. We need to make the questions feel tailored to the individual, making them feel heard and maybe a touch of empathy, but all without biasing them in any way. So that's the essence of adaptive follow-ups. And I think as qualitative researchers yourselves, you probably know that's a hard thing to learn to do and do consistently and effectively in an interview. But that's where AI can be really useful. Then the other thing is that we continuously refined our approach. So we would have a prompt and then we would evaluate it, see how well it did, and keep working on it. For example, when we first started out, sometimes the system It focused on really trivial details or asked impractical questions. For example, like if a respondent mentioned that the airplane seats were too close together, the follow-up might ask, like, how far apart should the seats be? And so that it was way too specific. It wasn't helpful. So we had to make changes, right? Instruct the model to focus on significant details and to elicit responses that are insightful and actionable to make sure that the follow-ups were good and relevant. And when we were happy with that prompt, that's when we did our proof of concept test. And so what we found was that when generative AI follow-ups were used, respondents were more engaged. So we asked respondents in both conditions how burdensome the survey was, and those in the AI follow-up group found that the survey was less burdensome to complete than those in the control, excuse me, despite answering more open-ended questions. And then for respondents in the AI condition who received at least one generative AI follow-up, we asked them how engaging the survey was compared to surveys without AI. About 2/3 found it to be more engaging, and then 31% said no different, and then only a small percentage, less than 5%, said that it was less engaging. So respondents were more engaged, and we found that responses were more insightful. So we found that 87% more topics were discovered when follow-ups were used compared to just looking at the original response. And then detection of meaningful, and by meaningful, I mean non-neutral sentiment, emotion, effort, or actionability, also increased by 20 percentage points. And both of these were assessed using Qualtrics Text IQ, which uses machine learning algorithms to automatically code the topics and the sentiments of open-ended text. And then Mike Carroll Haney also conducted another analysis of lexical diversity that showed that the percent of responses showing some lexical diversity increased by almost threefold. So if you're not familiar with lexical diversity, it refers to the range and variety of words used in a response. So it can be used to kind of provide insights into the richness and variability of vocabulary within a response. So it's a combination of both the uniqueness of words that are known to convey meaning as well as length. So as responses get longer, you would expect more unique words, but a lower percentage of unique words to total words. And so this algorithm accounts for that. So basically what we're showing is this, it's not just that you're getting more words, you're getting words that have more richness, more detail, more information in them. And I'll give more examples of lexical diversity when we get to study 2. And so now I want to talk about our observational study. And before I get to the results, I want to take a second to talk about what we did differently. So as I mentioned, with the first study, we used a generic LLM, ChatGPT 4 Turbo. But after we had that proof of concept, we switched to a fine-tuned model. So pre-trained LLMs are pretty good out of the box, just using a prompt, but they weren't built specifically for the purpose of asking unbiased follow-up questions. And so this is where fine-tuning can be used to improve the performance. Fine-tuning, if you're not familiar though, it requires a really comprehensive set of training data. And so it required continual evaluation and refinement, ensuring our examples were robust and reflective of real-world scenarios. So it was thousands of iterations and annotations with the training data. Because quality outcomes really depends on quality training data, we didn't want any surprises when our model went live. We wanted to know exactly how it was going to do. And so this study is an observational study. So that means that we didn't randomly assign people to one group or the other. The data was selected from eligible surveys from our early adopter customers that use the generative AI question between November 24th and mid-April of this year. And so this was over 100 different surveys with over 300 unique questions across a variety of topics. So then the data was anonymized and aggregated prior to analysis. And so that means that if the original question said, how satisfied are you with AAPOR, it was anonymized to say, how satisfied are you with organization? We also limited the analysis to just the first follow-up, just to kind of keep it simple. So there is an option in Qualtrics where you can allow either up to one follow-up or up to two follow-ups. And we found that most of the questions had a limit of one, as we didn't have enough data for the second follow-up. And then researchers in the platform, they can also indicate certain topics to avoid. So for example, if you're an airline, you can't do anything about people's experience with TSA. So you might instruct it not to follow up on any comments mentioning TSA. So that was something that we couldn't really control, but just recognizing that some of our customers might have specifically told it not to follow up on certain topics. Okay. So then what we found was that when generative AI follow-ups were used, participation remains high. So surveys that used Gen AI follow-ups had about 92% completion rates. And so that's quite high. And for purposes of comparison, the completion rate for all Qualtrics surveys during that same period was 84%. So we can't say that AI follow-ups improved completion rates because this was just an observational study. We know that completion rate is, is influenced by a number of factors that we didn't control, such as the survey length, topic, sponsor, incentives, etc. So likely these follow-ups were used on surveys that were already good. But my takeaway is that it's not hurting completion rates. It's not causing dropouts or anything like that. And then, and part of that is because, as you see there, our median time for that follow-up to load was less than a second. So a lot of times where you see kind of drop-offs due to AI is because it takes a long time. But that's one of the benefits of using the fine-tune model is that it's very fast and very efficient, and it feels like it's just another question coming up for the respondent. And so then we wanted to look at not just kind of completion rates and things like that, but how did the actual quality of the data change? And so when follow-ups were answered, we saw double the information, kind of no matter how we looked at it. So if we're looking at the original response plus the AI response, that doubled in comparing that to just the original response. We saw double the total words, double unique words, double total characters, all of that. Not too surprising because we're, essentially comparing two responses to one. But we also looked at lexical diversity and topics again, and we saw that that increased as well. We saw that the average lexical diversity scores doubled. And as I mentioned before, something to keep in mind with lexical diversity is that it factors in the length of the response. Because we would expect that a 50-word response, right, has more topics maybe than more unique words than a 25 question response. But it's kind of factoring in both those unique words and the length. And so I can provide an example of this. So if we take a look at this example, this initial response is really short, right? Very unresponsive, and it has a lexical diversity score of 0. So I wouldn't say this original response is non-insightful, but it's pretty vague. Was it the people who were unresponsive to the platform? What issue did she have that they were unresponsive about? Now we see that this response has a lot more detail and it has a higher lexical diversity score. And so now when we look at the combined value where we have that first response, very unresponsive, plus the detailed follow-up, the lexical diversity score is actually lower than when it was when we just had the original one. So as you can imagine, if the original response was really good, like the second response here, and then the follow-up generated a short, vague response, like very unresponsive, you could see how the combined score would decrease. And that did happen sometimes, but overall, it doubled. A lot of really kind of exciting and promising findings, but I did want to acknowledge some limitations with the analyses and the results that I just shared. As mentioned before, our second set of analyses were observational. That means that we didn't assign people to the AI follow-up condition or those without. So it's hard to draw conclusions with respect to completion rate. Another limitation is that our analysis focused just on the responses, but there's a lot of context in the question itself. We actually tried using AI to summarize the full response, the original question, response, AI question, and answer. And that worked even better, but I didn't have good, data to show you that that was better than just looking at the responses. So I didn't share that, but it is definitely something that as you're analyzing and using this information, that the questions that are asked are very relevant too. And then I also want to acknowledge that using generative AI follow-ups does introduce the potential for bias. The questions that get asked will be different for different respondents, and that could affect their survey experience. That being said, we used a fine-tuned model that mitigates some of this potential for bias because it introduces a lot more consistency than we saw when we just used ChatGPT 4 Turbo. We also did an extensive amount of annotation on the training data where we really assessed the generated follow-ups for things like bias to get that down to almost zero. Furthermore, the survey completion rates are high. If the use of AI follow-ups increased our dropout rates, then that would potentially lead to a different type of bias, but we didn't see that as well. So that's it. Thank you very much.
All right, thank you so much, Emily and Mary and Michael. Those are all excellent presentations. With that, let's turn to some questions. Okay. So I'm going to start with the chat. Well, since we have people with time and we can maybe go back, if the authors don't mind, you could answer in the chat. But like, does anyone have any questions, excuse me, that they want to ask in real time right now? Any hands? Okay. Oh, I saw a hand there. Annie, do you want to ask your question?
Hi, thanks everybody. Really helpful learning for me as a team of one. My question's for Michael. So you mentioned that you really want to look at the data, and I think this probably applies to all three to make sure it makes sense when it's popping out. And I agree with you that sometimes AI doesn't pop out what makes sense. How do you also control for, our own smoothing over of the data? How do we make sure that we're not contributing to like groupthink or pre-established, notions versus, okay, this is like not a good response from AI. What's the difference there? How do you think about that?
It's a great issue, and one that I'm not sure that anyone has a really great solution for when you're not using AI, right? Like, how do you think about when you have a team? When are you going down a biased rabbit hole, and when are you having the right kind of skepticism? So I think it's my take, and I'd be curious to hear what Mary and Emily have to think about this too, is that using an AI ends up making you think about that differently and forces you to in a way that maybe you wouldn't if you weren't using one of these tools to help you out. And it's just a thing to be guarding against. I mean, I do think that when one does qualitative analysis, it is the perspective of the researcher or research team that is what is needed and valued, and that's sort of the whole point of qualitative insight. So thinking of this as an additional team member who may bring their own messes to the table like everyone does, feels like it's probably the way to go. But I think, the guarding against when is it groupthink and when are you missing something is a problem, whether or not you have an AI there.
Yeah, and I'll just jump in that what's one thing I mentioned, and I'll mention again, is like it's so important for the researcher, if using AI in analysis, to be close to the data, to to really know the data. You can't just be like, oh good, I have some data, let me have AI interpret it for me. So we advise our researchers to, you have those, you collect the data, you have those debriefs, you have those debrief notes, really come up with what are your key insights. They don't need to be polished, they can be rough, because AI can help you polish them, but you need to know, like, what are you trying to say, what did you find? Then you can share that with the AI as part of the analysis, see, have it help you shape the story that you are telling, the AI you want to shape. But then you do also have this opportunity to ask the AI, what am I missing? Are there any other points? So you can kind of actually like do both. You should know your data, you should be driving the story, but then like, hey, let me also flip it over and say, like, is there anything else you might suggest or recommend? Again, always being cautious and always being thoughtful as to whether those recommendations make sense that you get provided.
Our approach is a little different because we're building for technology. So we have very strict evaluation criteria and validation criteria. So kind of observable metrics. And then as we make changes and iterate, we evaluate, okay, when we made this change to the prompt or this model, did it make it better? And we have that evaluation criteria that we can use. And then when we move to the fine-tuned model, we did have a series of annotators who review and annotate the results. And so for generating a follow-up question, we had very strict criteria about like what would make it good versus bad. And we have a category that's like high risk, right? That like this would be embarrassing. Our customers would stop using Qualtrics if they saw that. And that's something that when we did our model, we wanted to get that one down to 0. Because if there is anything that created this horrible experience, we're going to lose customers. And so as we looked at our evaluation and things like that, there's different ways that you can train for, right, this different types of errors. So we'd love to maximize the number of good. But if we had to reduce the number of like excellent and have a few more good, as long as it got the horrible down to 0, that was a trade-off that we were willing to make. And then our process for that is like we start with someone like myself who is an expert in qualitative interviewing, and I did like the early rounds and proof of concepts, and then I trained a broader annotation team, and we had to have them have some agreement on an initial set, kind of like what you do with inter-rater reliability, in order to kind of prove that they understood the criteria and that there was some reliability and consistency, and then they moved on to evaluate. And then once we got into other languages, it was even more of a challenge to kind of use to slightly modify our rubric to work for different languages, recognizing that some of these have slightly different meanings in those other languages.
Thank you. All really helpful.
Yeah. In the interest of time, it is noon. Can Michael, Emily, Mary, do you guys have to run, or could you stay a little bit for some more questions? Or
I can stay.
I can stay a minute. Yeah.
I can say.
okay, great. It seems like a lot of people are interested in John Borman's question about, for the social media review using LLMs, did you compare 2 runs of the same model against one another? I have found LLMs will often produce different results each time you do a run with the same data and same prompts.
Yes, so we saw that too, and sort of for the longer term, if one really wanted a science of how best to use this and when you get what results doing what things, then that would be another, like, the number of possible comparisons to see how making minor variations will make what kind of difference is enormous, and actually a real challenge, given that the models themselves change in a black box way behind the scenes when you're using these off-the-shelf ones, and that you don't have control over. So yes, different runs with the same model can lead to different, not often entirely different, but different enough that it's even worth doing the same thing with having the same prompts with different models. Also, depending on whether you've turned on the memory or not, it either remembers what it did before as it does the next run, or it starts afresh. And so that's another thing to be considering. In the same, I mean, my conclusion would be that in the same way as you would want to use the same prompt with different models, using the same prompt with the same model to see what you get is, another way of further querying in order to find out how much more you're getting. Is that answering what folks were looking for about that?
I don't see reactions, but I think so.
Okay. Okay.
Ollie had a question. Many thanks. Did you both use LLMs via API? If not, is the comparison fair? And I believe that would have been for you, Michael.
Yeah. So, I mean, I think what counts as really a fair comparison is a really fair question, right? Like, what is the right way to do this? We were interested in, okay, for researchers who don't necessarily have access to the API, and for different LLMs, access to the APIs varies and has different requirements and the like. We were using the interface that would be the not API version. So that's a different kind of fair, right? Another is, okay, if you're using the top of the line connection with every LLM using their API, do you get the same thing? So that is fair to ask what is really a fair comparison. Providing additional context and definitions of terms. In this case, we were not wanting to presuppose what the content would be, and it seemed giving definitions and terms would be problematic. On the other hand, you could imagine, so let's say we had trained the model on the outputs of all the focus groups and said, use these concepts in particular as you make your summaries. That would be another thing you could do. So, and would that be more fair? Maybe. I think from my perspective, figuring out what is scientifically the right and fair comparison at this moment is non-trivial, and there's an exponential profusion of possible comparisons that makes it unclear what the best way to think about this is. So that's where we are.
All right, thank you so much, Michael. I think in the interest of time, we should probably wrap up. Again, thank you so much. Really interesting topic and really useful insights from all three of you. Okay, thank you everybody for joining us, and please fill out the, yes, applause, fill out the post survey. I know we're really bad about that at AAPOR, but like just to give us tips and ideas for the future learning bursts. All right, thank you and have a great day, everybody.
Thanks, Kathleen. Bye, everyone.